There is a threat to a major American city, just 50 miles from its downtown core, that is not a financial collapse, not a political crisis, not a foreign adversary. It is a geological certainty, a clock that has been ticking for 500,000 years, and its alarm is beginning to sound. It's a threat that places over 150,000 people in the direct path of a force with the consistency of wet concrete and the speed of an avalanche. And it holds the water supply for 1 million residents hostage to a single catastrophic point of failure. This isn't a story about a volcano that will blow its top. This is a story about a volcano that will simply fall apart. It doesn't need a massive eruption. It doesn't need a column of ash. All it needs is gravity and its own internal heat. The recent shaking of the ground, a series of earthquake swarms culminating in the largest tremor in 2 decades, was not the main event. It was a memo, a geological notice that the system is active, it is pressurized, and it is unpredictable. What is it that you think is Portland's biggest weakness? Let me know in the comments below. Most of the people who watch our videos are not subscribed, and they miss the follow-ups to stories just like this one. Our work depends on your support. If you believe understanding these hidden threats is important, take 1 second to hit that subscribe button. It's a small click that makes a huge difference and ensures you won't miss what comes next. It's the most important thing you can do to support this channel. Let's begin. This is the story of Mount Hood. And it is not the story you think it is. The city of Portland, Oregon looks at Mount Hood every single day. They see a landmark, a postcard, a symbol of the Pacific Northwest's rugged, pristine beauty, a recreation hub for skiing, for hiking, for solace. But the United States Geological Survey sees something else entirely. In their official 2018 assessment, they classified Mount Hood as a very high-threat volcano. Not a moderate threat, not a high threat, very high. A designation reserved for the most dangerous volcanic systems in the nation. The reason for that assessment is not what you see on the surface. It is what brews deep inside, and what has happened dozens of times before. Mount Hood is not a Mount St. Helens. It is not building pressure for a single cataclysmic lateral blast. It is a different kind of killer. A quieter, more insidious one. It is a stratovolcano, built layer upon layer by thick viscous lavas of andesite and dacite. This magma doesn't flow like Hawaiian lava. It oozes. It piles up. It builds steep, unstable domes of semi-molten rock high on the volcano's flanks, and domes eventually collapse. This is the central mechanism of Mount Hood's destructive power. When one of these domes gives way, it doesn't just cause a landslide, it depressurizes violently, unleashing a pyroclastic flow, a 100-mile-per-hour avalanche of superheated gas, ash, and incandescent rock fragments. But the rock is only the first part of the weapon. The second part is the ice. Mount Hood is draped in 12 named glaciers, billions of gallons of frozen water locked in place. When a pyroclastic flow traveling at hundreds of degrees Celsius hits that ice, the result is instantaneous and apocalyptic. The glaciers flash melt, and the water mixes with the ash, the soil, the boulders, the trees, and everything else in its path. It creates a lahar. A lahar is not a flood. A flood is water. A lahar is a slurry of volcanic debris that moves with the density of liquid concrete. It can be hot or cold. It can carry boulders the size of houses. It does not flow around obstacles. It picks them up and carries them along, or it buries them completely. It fills entire river valleys from wall to wall, setting like cement when it stops. The geologic record is unambiguous. Lahars from Mount Hood have, in the past, traveled the entire 50-mile length of the Sandy River, all the way to its confluence with the Columbia River. And today, more than 150,000 people live, work, and sleep on top of the deposits left behind by those ancient flows. They live in a pre-carved channel of destruction. And here's the part that keeps geologists awake at night. The volcano doesn't even need to erupt in the traditional sense to make this happen. For decades, the hot vents and fumaroles near the summit, particularly around a feature called crater rock, have been pumping out acidic gases and superheated fluids. Surface temperatures there hiss at 192 degrees Fahrenheit. But geochemical analysis suggests the deep hydrothermal system is cooking at over 570 degrees. Those fluids are not inert. They are chemically aggressive. For centuries, they have been percolating through the mountain's core, slowly but relentlessly altering the hard, stable dacite rock. It's a process called hydrothermal alteration. A simpler way to say it is this: Mount Hood is rotting from the inside out. The acids are turning solid rock into weak, slippery clay. The mountain is digesting itself. This creates a terrifying possibility. A catastrophic collapse of a summit dome doesn't require new magma pushing from below. It could simply happen under the force of gravity alone. A section of the volcano, weakened and rotten, could just let go on a quiet Tuesday, on a clear summer day, without any new eruptive activity at all. And if that collapse is large enough and it hits the glaciers below, the result is the same. A massive, unstoppable lahar, born not from an eruption, but from a simple, catastrophic failure of internal structure. And a failure like that happened much more recently than you think. Christmas Day 1980, while the world's attention was still fixed on the aftermath of Mount St. Helens, Mount Hood delivered a quiet, deadly lesson. There was no eruption, no magma, just a severe rainstorm. The intense rainfall saturated the steep, loose slopes of Palali Creek on the volcano's northeast flank. The waterlogged soil and rock gave way, creating a massive debris flow. Not a volcanic mudflow, just a terrestrial one. It roared down the canyon, damming the East Fork Hood River. 12 minutes later, that natural dam breached. The resulting surge of water, mud, and debris wiped out more than 10 kilometers of Highway 35, caused $13 million in damages in 1980 dollars, and killed one person. It was a tragedy. But to geologists, it was also a field test, a proof of concept. It demonstrated that the mountain's slopes were so unstable that even heavy rain was enough to trigger a lethal, infrastructure-destroying flow. Now imagine that same event, but instead of just rain-saturated soil, the trigger is thousands of tons of superheated rock from a collapsed lava dome. Imagine it hitting not just soil, but a glacier. The Palali Creek disaster was a miniature. The real thing would be an entirely different order of magnitude. What do you think is the most overlooked danger in our modern world? Share your perspective in the comments. It helps us understand what topics matter to you the most. The history of Mount Hood is written in these flows. This is not a new threat. It is an ancient and repeating cycle. We just chose to forget. Go back 1,500 years to what geologists call the Timberline eruptive period. For decades, or perhaps centuries, the volcano was in a state of constant, violent flux. Lava domes grew and collapsed, one after another, sending enormous lahars surging down the slopes. These flows were so massive they filled the ancient river valleys, building up the landscape, creating the very ground on which modern life now sits. The famous Timberline Lodge, a National Historic Landmark that served as the exterior for the Overlook Hotel in the film The Shining, is an icon of mountain architecture. Tourists flock there. They ski on the slopes below it. They take pictures of its grand facade against the backdrop of the peak. They have no idea that the lodge itself is built directly on top of the hardened debris from a pyroclastic flow and lahar deposit from that very eruptive period. The ground beneath their feet is the tombstone of a previous cataclysm. They are vacationing on a geological crime scene. It gets more specific. It gets more recent. The last major eruptive period began around 1781. It is known as the Old Maid eruptive period, and it was a textbook example of how this volcano operates. It began with the slow extrusion of a new dacite lava dome, the feature we now call crater rock, the same one that is steaming and rotting from within today. That dome grew, became unstable, and then collapsed. Repeatedly, for roughly 30 years, hot avalanches and massive lahars scoured the mountain's flanks. They raced down the Sandy River, the Zigzag River, and the White River. They were so voluminous that they completely filled the Sandy River Valley for miles, creating a broad, flat plain of volcanic sediment, a place now called Old Maid Flat. It's a popular recreation area, a place for hiking and camping. It exists only because a volcanic mudflow wiped the previous landscape clean and paved it over. In November of 1805, 2 American explorers arrived at the mouth of a river feeding into the Columbia. Their names were Meriwether Lewis and William Clark. They were on the final leg of their transcontinental journey. When Captain Clark reached this particular river, he noted something strange. The water was choked with sediment, a thick, gray, mobile sludge. It was so dense, so unlike a normal river, that he gave it a new name. He called it the Quicksand River. Today, we call it the Sandy River. What Clark was seeing, what he was documenting in his journal, was the direct, fresh aftermath of the Old Maid eruption. The river was still suffocating on the volcanic ash and debris that had poured down from Mount Hood just a few years earlier. Lewis and Clark were looking at a river that was still bleeding from the mountain's last major fit of activity. They gave us the first eyewitness account, a warning written into the foundational record of American exploration. And what did we do with that warning? We built highways across those lahar paths. We built communities directly on top of the quicksand deposits. We engineered a society that depends, for its very survival, on the assumption that the river will stay in its banks. The volcano has repeatedly shown us otherwise. It told us exactly how it would try to kill us. And we built our homes in the kill zone anyway. Sharing this video with your family and friends could be the most important thing you do today. It's not just a story. It's a public safety issue that affects an entire region. If you found this information valuable, please hit the like button. It tells the algorithm that this is a conversation worth having. The shaking is what gets the headlines. The small earthquake swarms that periodically rattle the volcano. They are reminders. Tectonic throat clearing. On June 5th, 2021, a magnitude 3.9 earthquake struck just south of the summit. It was the largest quake at the mountain since a magnitude 4.5 event back in 2002. It was felt by residents in the surrounding towns. It lit up social media. It was a jolt, a physical reminder that the colossal thing on the horizon was not dormant. It was merely quiet. Then, between December 8th and 13th, 2023, a more subtle swarm occurred, too small to be felt by most people, but perfectly clear to the sensitive instruments that now guard the mountain. The USGS Cascades Volcano Observatory, the CVO, was watching. Named in honor of David A. Johnston, the volcanologist killed at Mount St. Helens in 1980, the CVO is responsible for monitoring Mount Hood's every tick and tremor. Scientists there, people like former research seismologist Seth Moran, maintain that these swarms are common. They are part of the mountain's background noise, likely caused by the movement of hydrothermal fluids or minor slips on regional fault lines. They are not, in themselves, direct proof of an impending eruption, but that is a dangerously simplistic way to look at it. The swarms are a symptom of an active system. The volcano has a pulse, and sometimes that pulse quickens. The real problem is the speed at which a quiet pulse can become a critical emergency. In a 2019 press release, Seth Moran laid out the challenge in stark terms. Robust monitoring networks are a key tool, he said, because volcanoes can awaken rapidly, in just days to weeks, and initial precursors to that awakening can be subtle. Days to weeks. The transition from background noise to active crisis might not be a slow, multi-year crescendo. It could be a sprint. That is the nightmare scenario. Not a long, drawn-out warning, but a sudden, rapid escalation that leaves authorities with hours, not months, to react. I know this is the second time I'm asking, but the data shows that a huge number of you who find this content essential forget to subscribe. It is the single most effective way to help us continue this research and these deep dives. Please take this one moment to do it. It matters more than you know. This urgency is why, between 2019 and 2020, the USGS undertook a critical upgrade of Mount Hood's monitoring network. They installed 3 new, state-of-the-art monitoring stations high on the volcano's flanks, within 2.5 miles of the summit. These weren't just standard seismometers. They were complex instrument packages, helicoptered into the wilderness, designed to act as a comprehensive early warning system. They contain GPS receivers to detect millimeters of ground deformation, the telltale sign of magma moving and swelling the ground from below. They have sensitive seismometers to pick up the faintest tremors. And they have gas sensors, sniffers, that can detect subtle changes in the chemistry of the gases venting from the fumaroles. A change in the sulfur dioxide ratio, for instance, might be the first clue that new, fresh magma is rising from deep within the earth. This network is the tripwire. It is designed to catch the subtle precursors that Moran warned about, to turn days to weeks of warning into something officials can actually act on. It is a technological shield against a geological inevitability. But even the most advanced shield has a weak point. For Portland, that weak point is not ashfall. It is not a lava flow, which on a volcano like Hood are too thick and pasty to travel more than 6 or 8 miles. The Achilles heel of the entire Portland metropolitan area is its water. Nearly 1 million residents of Portland and surrounding communities get their drinking water from a single source, the Bull Run watershed. It is a pristine, federally protected area in the Mount Hood National Forest, renowned for the quality and purity of its water. The good news is that the Bull Run reservoirs themselves are geographically shielded from the volcano. A high natural ridge separates the watershed from Mount Hood's main drainages. No lahar from the Sandy River or Zigzag River can physically flow uphill and over that ridge to contaminate the reservoirs. The water source itself is safe. The delivery system is not. To get water from the Bull Run reservoirs to the taps of 1 million people, the Portland Water Bureau relies on a series of massive pipelines, conduits that carry the city's lifeblood. And those pipelines, at a critical juncture, cross directly over the Sandy River, the same Sandy River that was the quicksand river of Lewis and Clark, the same Sandy River that is the primary pre-carved superhighway for a major lahar. If a large lahar comes down that valley, it will not be a gentle flood. It will be a high-speed torrent of mud, rock, and debris with the power to scour the valley clean. And those pipelines are sitting directly in the line of fire. They would not be damaged. They would be obliterated. Severed, gone the city would not lose its water because the source was poisoned. It would lose its water because the straw it was drinking from had been snapped in half. Instantly, 1 million people would be cut off from their primary water supply, with no immediate large-scale backup. The crisis would be instantaneous. The engineering challenge to repair that breach, while the river valley itself might be buried under tens of feet of debris that could take months or years to stabilize, would be monumental. This is the single greatest threat Mount Hood poses to Portland. A surgical strike against a single piece of critical infrastructure, executed by a mudflow that has happened before and will absolutely happen again. The question of when is a matter of unsettling probability. In 1997, the USGS published its formal hazard assessment for Mount Hood. In it, they made a calculation that should have set off alarm bells in every city planning department in the region. Based on the geologic record of how often lahars have occurred in the past, they estimated the 30-year probability of a major lahar burying a given site within the hazard zones of the Sandy or White River valleys. The odds were between 1 in 15 and 1 in 30. Let that sink in. A 3.3% to 6.7% chance within any given 30-year window. Those are not astronomical odds. Those are the odds of a house fire, of a major car accident. Those are palpable, manageable risks that we buy insurance for. But how do you buy insurance for a river valley being filled with volcanic concrete? How do you mitigate a risk that involves 150,000 people and the water supply for 1 million more? The clock on that 30-year probability started ticking in 1997. We are now well past the 2/3 mark of that window, and the volcano has begun to stir. The science is certain. The monitoring is in place. The historical precedent is undeniable. And yet, the paradox remains. We know with chilling precision how the catastrophe will unfold. We have reports, maps, and models that lay out the inundation zones in painstaking detail. We have a network of instruments capable of giving us a warning. But that warning may only be weeks long, maybe just days. What can a society do with a few weeks' notice? Evacuate 150,000 people from their homes? Reroute the entire water supply infrastructure of a major American city? The sheer inertia of our built environment is a force almost as powerful as the volcano itself. The houses are still there. The pipelines still cross the river. The deep internal rot of the mountain continues, day after day, whether we are paying attention or not. The earthquakes are not the threat. They are the notification. They are the planet's way of tapping us on the shoulder, reminding us that the ground beneath our feet is not as solid as we pretend it is. The third time is the charm, right? I hate to interrupt again, but my producer tells me our subscriber numbers are the one thing holding our channel back. If you've watched this far, you are one of the most engaged viewers we have. Please, just take the second to hit subscribe. It's what keeps these documentaries going. Thank you. We are left with a profound and deeply uncomfortable truth. Mount Hood is not a question of if, but a question of when. The engineering that watches the mountain is a modern marvel, but it is a passive observer. It is an alarm system, not a shield. It can tell us that the disaster is coming. It cannot stop it. The story of Mount Hood is now a race between geological time and human reaction time. One moves at an inexorable grinding pace. The other moves at the speed of policy, of economics, of denial. The great irony is that the danger is not from some unknown mysterious force. It is from the most basic elements of our world: rock, heat, and water. A combination that has built our landscapes and can, in a matter of hours, unbuild our cities. The latest tremors were a whisper. The next warning may not be so quiet. The volcano has shown its hand, time and again. The final terrible question